Hello students. Today let us discuss some basic aspects of matrix algebra. Now starting from the definition. Now we all know how the matrix has been represented. So basically it is a rectangular array of numbers arranged in rows and columns enclosed by a pair of brackets. So we have seen the examples. Now you see it can be written as 1, 2, 3, 4, 5, 6, 7, 8, 9. Here you see the shape of the bracket. So it is not necessary to write every time with this type of bracket. You can also write in the other forms. Say for example, the next one you see, second example, it is 1, 3, 2, 6, 5, 4, 3, 1, 8, and you see the type of bracket used. Or it can also be written in this form. But usually we will write this first or the second form. This is how we represent the matrix. Now coming to the order of the matrix. Now what do you mean by order of the matrix? Let me write here one example. See here. Let us call this as matrix A. For example, 1, 2, 3. Then 4, 5, 6, 7, 8, 9. It can be any number. You see here, this matrix, in this matrix, so this is the first row, and this is the second row, and this is the third row. In the same way, here you see this 1, 4, 7. This is the first column. This is the second column, and this is the third column. So here, order of the matrix means this is if a matrix has m number of rows and n number of columns, then the matrix has an order m into n or m by n. This is how we read it. So order of the matrix is denoted at the right bottom corner of the matrix. So in this example, you see here, there are 3 rows and 3 columns. So 3 rows and 3 columns. This is how we represent. So it has to be represented at this position only. So since there are 3 rows and 3 columns, this is how we write. So it not necessarily be always 3 rows and 3 columns. We can also write it in another way. Say for example, let us write here example B. So here let us write 3, 4 and 6, 9. Now you see there are 2 rows and 2 columns. So here the order is 2 by 2. Now one more example, let us see. Matrix C. So here 1, 2, 3, 4, 5, 6, 7, 8. This is another type. So here there are 2 rows and 4 columns. So number of rows are 2, number of columns are 4. So we can write the order as 2 by 4. So this is how we write the order. I hope this is clear now. Now coming to the types of matrices. So there are many types of matrix, and these are important for the examination purpose. So square matrix, what is the condition? A matrix in which the number of rows is equal to the number of column. So for example, let us take one matrix A. Example, matrix A. So here this is 1, 2, 3, 4. Here you see this is so here there are 2 rows and 2 columns, so we can write this as a 2 by 2 matrix. Example B, the only condition is number of rows and number of columns should be same. So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9. You see here there are 3 rows and 3 columns. So here it is 3 by 3. So a matrix in which number of rows is equal to the number of column is called as a square matrix. And here you see there is something called as a diagonal. There are two diagonals in this matrix. So one is the principal diagonal, that is diagonal extending from the upper left to the lower right. That means this one. You see 1, 1, 5, 9. So you see this is the diagonal. This is the diagonal here. So 1, 5, 9. This is the principal diagonal. So whenever we say diagonal of a matrix, let us consider the principal diagonal only. Alright. So now coming to the second one, that is the row matrix. If the matrix has only one row, for example, matrix A, that is equal to 1, 2, 3. So it has only one rows. So we write this as 1 by 3. It has one row, but there are 3 columns. So 1 by 3. Or another example you can consider, this is 1, 2. So here also the number of rows is only 1, but number of columns are 2. Don't worry about the number of columns here. If it has only one row, then it is called as a row matrix. Column, here it is exactly opposite. So if the matrix has only one column, then it is called as column matrix. It can be any number of rows. For example, matrix A can be written as 1, 2, 3. You see there are 3 rows, but we are not bothered about that. So only condition is it should have only one column. One more example. Here you take this as 2 and 4. So there are 2 rows and 1 columns. Any number of rows, let it be, it is not a problem at all, but only it should have 1 column. This is the only. Fourth one is about the diagonal matrix. Here it is a square matrix only, in which the diagonal elements are non-zero and other elements are 0. So for example, let's take matrix A. So A is 1, 0, 0, 2. So this is basically a 2 by 2 matrix, but you see this is the diagonal. So across the diagonal, the element should not be 0. That is the criteria. One more example, let's see. Matrix B. Matrix B is -1, 0, 0, 0, 2, 0, 0, 0, 3. This is a 3 by 3 matrix, but you see here the diagonal. This is the diagonal, and the diagonal elements are non-zero. So such matrices are called as diagonal matrix. Now next one is extended version of the diagonal matrix, that is called as a scalar matrix. So here the all the principal diagonal elements should be same. That is the condition. So let us study some examples also. So matrix A is, the diagonal element should be same, right? So any example, so 2, 0, 0, 2. So here you see the diagonal elements are 2 and 2, that is non-zero. One more example, matrix B, you take it as a 3, 0, 0, 0, 3, 0, 0, 0, 3. So here also you see this is the diagonal element, right? So here the diagonal element should be same, that is 3. Not necessarily only 2 or 3, any number, it can be 5, 6. So all the diagonal elements should remain same. Then we can consider it as a scalar matrix. Now unit matrix. In unit matrix what happens is the diagonal element should be 1. That's the only condition. So matrix A is equal to 1, 0, 0, 1. Or matrix B, if you want to consider a 3 by 3 matrix, it will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So here this is a unit matrix which is also called as identity matrix. Next, the seventh one, this is the null matrix or zero matrix or void matrix. So as the name indicates, zero matrix, all the elements in this matrix should be equal to 0. That is, if you write an example, A, matrix A. So if you want to represent a null matrix, and if it is a 2 by 2 matrix, all 4 elements should be equal to 0. Or you write one more example in which all the elements, this is a 3 by 3 matrix, so all elements should be 0. So this is an example of zero matrix. Next comes the upper triangular matrix. So here the elements below the leading diagonal should be 0. Leading diagonal or principal diagonal, it is same. So the elements below the leading diagonal should be equal to 0. So for example, matrix A, that is equal to 1, 3, 4, 0, 2, 5, 0, 0, 3. So here let us consider the diagonal matrix. Diagonal matrix, you know that this is the diagonal matrix. 1, 2, 3. This is the diagonal element. Now you see the upper, here it is non-zero. Here it is 0. You see below the diagonal matrix it is 0. So this forms the shape of a triangle. Therefore the name comes triangular matrix. So next one is lower triangular matrix, exactly opposite. In this matrix, the elements above the leading diagonal should be 0. So not below one. If it is below, then it is upper triangular matrix. If the elements above the principal diagonal is 0, then it is called as lower triangular matrix. For example, here 1, 0, 0, 4, 3, 0, 2, 6, 9. So in this example, you see 1, 1, 3, 9. This is the principal diagonal. Above this is 0, you see. So below it forms the shape of a triangle. Therefore the name comes lower triangular matrix. Next one is the submatrix. Now let's see what submatrix is. Let me represent a matrix first. So let us call it as a matrix A. It can be a 2 by 2 or 3 by 3 or 4 by 4. Let me write one example of a 4 by 4 matrix. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can write any numbers randomly. Need not be in order. 13, 14, 15, 16. So this is a 4 by 4 matrix. Now here what I will do is, let me delete the last column. Let me delete this one. And let me also delete, not necessarily, any column deleted also, the remaining what we get is a submatrix only. Let me delete one more row. That any row I can delete. So let me delete the last one here. Now what will happen is, when I delete one row and one column, what is remaining now? Now you see that is called as the submatrix. So submatrix is equal to, now it is 1, 2, 3, 5, 6, 7, 9, 10, 11. So this is the submatrix of a given matrix. Okay. Next, 11th one. that is transpose of a matrix. Here, this type of matrix is obtained by interchanging the rows and columns of the given matrix. Again, let us understand this with one simple example. Let me write the given matrix as 1, 2, 3, 4. Now, how to find the transpose of a matrix? Transpose can be written as AT, or it can also be written as A dash. Both are representation for transpose of a matrix. So, as we discussed in the statement, the rows and columns are interchanged. Now, first row becomes the first column. So, 1, 2 is the first row there. Now, that becomes the first column here. So, 1, 2. The second row becomes the second column. That is 3, 4. So, this is the transpose of a matrix. Next one is symmetric matrix. So a matrix in which transpose of a matrix is equal to the given matrix. That means if when we take the transpose of a matrix, that is A dash, if this A dash is equal to A, then they are called as symmetric matrix. For example, matrix A is 1, 0, 0, 0, 1, 0, 0, 0, 0. Now let's take the transpose of this matrix. The transpose of this matrix, that is A dash, that means what we have to do here? The first row becomes the first column here. So 1, 0, 0. The second row becomes the second column, that is 0, 1, 0. The third row becomes the third column, that is 0, 0, 0. So now when you compare, is this not the same as the given matrix, that is A? See, 1, 0, 0, 0, 1, 0, 0, 0, 0. It is A only. So in this case, the transpose of a matrix and the given matrix are same. Such type of matrix are called as symmetric matrix. Last type of matrix is skew symmetric matrix. Now, a matrix in which transpose of a square matrix, that is transpose of a square matrix, A dash, is equal to negative of the given matrix, that is minus A. So that means, let us understand this with an example. So let the given matrix be 0, minus 8, 3, 8, 0, 4. Sorry, minus 4 let us take. Then here it is minus 3, 4, 0. This is the given matrix. Now let's find the transpose of it. Let's find the transpose of this matrix. So transpose of this matrix, that is A dash. Now as you know, the first row becomes the first column here. So 0, minus 8, 3, 8, 0, minus 4, minus 3, 4, 0. Okay, this is the transpose. Now you see here, if you look at the numbers, they're all the same type of numbers. Only thing is, you take this minus outside and minus outside, and now rewrite this 0 only. We want 8 there, so minus is taken out, so this becomes minus 8. So minus of minus becomes plus only. So next one is minus 3. Since minus is taken out, you can only write it as 3. Then here the same, minus is already existing outside, so you make it as 8. 0 has no effect. So this you make it as minus 4. So minus into minus taken outside, minus minus becomes plus. So here it is, we want, what is that? Plus 3. So minus already taken out. So you have to write this as minus 3. Minus, for the next number, minus 4. So minus is taken out. So you make it as 4. 0 has no effect. So now you see, what is this within the bracket? This matrix, is it not the same as the given matrix? 0, minus 8, 3, 8, 0, minus 4, then minus 3, 4, 0. So this is nothing but minus A, minus A. So this fulfills the condition. The transpose of a matrix is equal to negative of a given matrix. Such type of matrix is called skew symmetric matrix. Now let us move on to the scalar multiplication of a matrix. This is very simple actually. Let us consider a few examples here. Now one example, a scalar is nothing but a number. So here let us consider one matrix, say for example, if A equal to 4 minus 3, 8 minus 2 minus 1, 0. Okay, this is a given matrix and you are asked to find 4A. How to find 4A? This is easy actually. You have to multiply 4 to the given matrix. So what is that? 4A means 4 into the given matrix. What is it? 4 minus 3, 8 minus 2 minus 1, 0. So when you multiply, what you get is direct multiplication. So when you multiply 4 with 4, 4 into 4 is 16, 4 into 3 is 12, but with the minus sign there since it is a minus 3. Then 8 into 4 is 32, then 4 into minus 2 is minus 8, then 4 into minus 1 is minus 4, and 4 into 0 is 0. See, direct multiplication. So scalar multiplication means multiplying a number uh, to a given matrix. So this is the answer that we get. 4A means this one. Okay. Next question. You are asked to prove that a given matrix is symmetric. So what is that given matrix? Let us write the question, rewrite this question again. Prove that given matrix A. What is A? This is given in the problem. 1, 4, 5, 4 minus 3, 0, 5, 0, 7. You have to prove that this matrix is symmetric. This matrix is symmetric. So how to prove that it is symmetric? What is the condition for symmetric? Symmetric condition is the given matrix and its transpose should be same. So how to do it? How to solve this? So solution is you directly calculate the transpose of a given matrix. What is the transpose? How to write the transpose? The first row becomes the first column here. So 1, 4, 5. Second row becomes the second column. 4 minus 3, 0. Third row becomes the third column, that is 5, 0, 7. Now you see, is it not the same as the given matrix? That means this is equal to the given matrix itself. So if transpose is equal to transpose is same as the given matrix, then it is symmetric. Therefore the given matrix is symmetric. Okay, very easy, it is direct. Next, there is one problem given. You are asked to find x and y. So find x and y if the condition given, you see here, if the condition is, the question is like this. This is a matrix x plus y 2. Then here it is 1. Here it is x minus y. Okay, that is equal to, this is given, this is the question what I am writing here, 3, 2, 1, 7. So you are asked to find x and y. So how will you solve this? Look here. Solution. Now what you do is you compare this x plus y with its counterpart. What is its counterpart? 3. So what you get? X plus y is equal to 3, which means x can be written as 3 minus y. Let us call this as equation 1. In the same way, now what we will do is, you see this x minus y. This x minus y you compare with the 7, its counterpart, right? So x minus y is equal to 7. So what is x? X from here, you see, from this, let us substitute for x as 3 minus y. Then minus y, which is already existing. It is equal to 7. So this is 3 minus 2y is equal to 7. That is 3 minus 7 is equal to this minus 2y, you take it to the other side, it becomes plus. So this becomes 2y. So 3 minus 7 is minus 4. So minus 4 is equal to 2y, or y is equal to, what is it? Minus 4 divided by 2, that is equal to minus 2. So y is equal to minus 2, correct? Therefore what to do? Therefore from equation 1, what is x equal to? 3 minus y. What is y? Minus 2, right? Minus 2. So this becomes 3 plus 2, that is equal to 5. So what is the conclusion? Therefore, 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 x is equal to 5 and y is equal to minus 2. This is the answer. Now we'll work out few more problems. So the question is given, find xy if 4 5 plus xy is equal to 7 3. So this is the type of matrix, you know, this is having only one row, right? So this is the row matrix. So how to solve this? The solution is very easy here. You just have to write like this. So this 4, you can solve it in this manner. 4 plus x is equal to 7. So what is x equal to? 7 minus 4. So what is x? 7 minus 4 is 3. So it's direct. In the same way, how to find for y? 5 plus y is equal to 3. Y is equal to 3 minus 5, that is minus 2. Over. Same way, the next problem. Find xy if 1 minus 9 minus 2 minus 3 is equal to xy. So how to do it? In the same manner, let's try. So 1 minus 2 is equal to x. So minus 1 is equal to x. That means x is equal to minus 1. So in the same way, how to write it? Minus 9 minus of minus 3 is equal to y. That is minus 9. This minus of minus is plus. So minus 9 plus 3 is equal to y, or this is minus 6 is equal to y, which means y is equal to minus 6. So x is equal to minus 1, y is equal to minus 6. Next problem is also the same type. All the three problems are of the same manner. So here x, y minus 0 minus 1 equal to 5, 4. That means x minus 0 is equal to 5, which means x is equal to 5. Then y minus of minus 1 is equal to 4. That means y minus of minus is plus. So y plus 1 is equal to 4, or y is equal to 4 minus 1, that is equal to 3. Let's move on to the next problem. Here you are asked to find, A is given, B is given. You are asked to find A plus B. Now let's see what is A. So A is, if A is 2, 3, minus 1, minus 3, minus 1, 4, and B is, this is the question what I am writing. So if A, so let me write the question again. If A is equal to, as written, and B is equal to 2, minus 1, 3, 7, 2, minus 1. You are asked to find A plus B, right? So how to find A plus B? Let's see the solution. This is direct addition. So solution is direct addition, A plus B. So write A, every step carry marks, so write it. So A is 2, 3, minus 1, minus 3, minus 1, 4, plus B. B is 2, minus 1, 3, 7, 2, minus 1. So when you add this, what are we getting? It's a direct addition, right? So 2 plus 2. So this 2 plus 2 is 4. Then 3 minus 1 is 2. Minus 1 plus 3 is minus 1 plus 3. Minus 1 plus 3. Okay. So what are we getting? Minus 1 plus 3 is 2. Then minus 3 plus 7. Minus 3 plus 7 is 4. Then minus 1 plus 2 is 1. And 4 minus 1 is 3. So this is the answer. Okay. Then next problem. In the same question, the numbers are same, matrix A and B are same. You are asked to find A minus B. So A is given. Let me write the question here. A is 2, 3, minus 1, minus 3, minus 1, 4, and B is 2, minus 1, 3, 7, 2, minus 1. Okay, you are asked to find A minus B. So how to find? Just earlier we added, right? Now it is the subtraction. So how to solve A minus B? So A minus B. What is A? 2, 3, minus 1, minus 3, minus 1, 4, minus B. What is B? 2, minus 1, 3, 7, 2, minus 1. So this becomes 2 minus 2 is 0. 3 minus of minus 1, that is 3 plus 1, that is 4. Minus 1 minus 3 is minus 4. Minus 3 minus 7 is minus 10. Minus 1 minus 2 is minus 3. And 4 minus of minus 1 is 4 plus 1, that is 5. Direct subtraction. Now we'll move on to the next problem. Here, if A is equal to, this is a question what I am writing, 0, 2, 3, 2, 1, 4. This is matrix A, and matrix B is 7, 6, 3, 1, 4, 5. You are asked to calculate 2A plus 3B. How much is 2A plus 3B? Okay. So, first one is a scalar multiplication only, first step. So, how to solve this? First you find 2A, that is 2 into 0, 2, 3, 2, 1, 4. So, direct multiply. 2 into 0 is 0, 2 into 2 is 4, 2 into 3 is 6. Then 2 into 2 is 4, 2 into 1 is 2, 2 into 4 is 8. Okay, this is 2A. Now, if you want to find 3B, 3B is equal to 3 into, what is B? 7, 6, 3, 1, 4, 5. So, when you do this, what do you get? 3 into 7 is 21. Then 3 into 6 is 18, 3 into 3 is 9, 3 into 1 is 3, 3 into 4 is 12, 3 into 5 is 15. So this is 3B. Now what we are asked to calculate is 2A plus 3B. So we have to just add this. What is 2A? 2A is 0, 4, 6. 4, 2, 8. So this plus 3B. 3B is 21, 18, 9, 3, 12, 15. So when you add this is a direct addition as we did earlier. So when you add this, 0 plus 21 is 21, 4 plus 18 is 22, 6 plus 9 is 15. Then 4 plus 3 is 7, 2 plus 12 is 14, 8 plus 15 is 23. So this is the answer.